You probably heard about Sora by now. Everybody in the AI space is talking about it. It's OpenAI's new tool for animating still images, but it's way more than that. By the time we're done with this video, you're gonna see why it's kind of unsettling, super fascinating. But if you extrapolate what happened, it definitely puts me on like wobbly ground. Of course, the first day I was looking at it thinking, wow, that's just super impressive. A big leap forward. OpenAI just has really talented people. They, fixed up the little things around the margins, used a much bigger data set, and like made the next advancement. Assuming that it's similar to tools like Runway ML, which I use in every single video. I love creating video from text. Runway ML, Pico Labs, Google Phenaki, Meta's Make a Video. I've experimented with them all. This is fascinating stuff, and there's something magical about using image generation, tying it together in a cohesive way, and I know it does funky stuff right now. So I just thought that's how this was going. But then I got a chill down my spine when I read this. When trained at scale, we find that these video models exhibit a number of interesting emergent capabilities. Okay, so yeah, like not expecting an emergent capability is like pretty much the definition of how the singularity destroys the planet, but I'm sure this is not a big deal because it's just like text, nothing to worry about yet. And that is true, right? Like the capabilities that enable Sora to simulate some aspects of people, animals, and environment from the physical world, they emerged without any explicit bias. And it's true, like I'm not literally scared of this project in any sense, but these capabilities, which I'm going to talk about in a second. Like I assumed I was going to see the model built in a different way, but these capabilities enable Sora to simulate some aspects of people, animals, and environments from the physical world, right? These properties emerged without any explicit inductive basis for 3D objects. They're purely a phenomena of scale. Think about that for a second. Would you ever have expected the whole idea of 3 dimensions to just emerge? Like, we build entire video game simulations that use, that's what GPUs were basically first used for, was like actually moving around in a 3D environment. I didn't expect it to pick up the depth to simulate the things that are behind people just by watching lots of 2D information. It just hit me hard. Sora can generate videos with dynamic camera motion. As the camera shifts and rotates, people in the scene elements move consistently through 3-dimensional space. It has no problem going behind you and generating the backside of you from a photo, from a video. Look at these scenes. They're walking and it knows height and depth, and this is very much like a video game. This is not Unreal Engine putting tons of 3D data into a model and then training it on that data so it generates 3D models. There's projects like that, there's tons of them. This is not one of them. Okay, so here is something that would be done in a 3D game engine, Minecraft. So look, this Sora model can simultaneously control the player in Minecraft with a basic policy. One way I usually visualize the concept of policy, I've done this for years, is with like a Nintendo controller or a PlayStation controller or something. Like the policy kind of limits you to like how you can move in some directions or something like that, but it can also be as big as ethics and whatnot. But basically it's got a policy. It knows how this Minecraft world works, how it can move around in there, while also rendering the world and its dynamics in high fidelity. So it knows how to work correctly in this environment, like move around it and play in it and give the same user experience of somebody playing it without it even existing, without playing it, without it being running in any sense. Like I'm kind of thinking, could you just put a video game controller up to this and then start saying like, go forward? And that's kind of the equivalent of like typing, like move the character forward. And we're already to the point where we're playing completely unique video games. Like this Minecraft thing seems like it's a step away from that. And I expected this years from now. Okay, so now the conversation has completely changed from whether or not this is a new video tool or is this a simulator, a reality simulator in its infancy. And of course, there's limitations on this model specifically, but I'm not even worried about this model in particular. But to be frank, it doesn't accurately model physics. It doesn't get basic interactions completely right. They have this example of glass shattering. Eating food doesn't always yield correct changes. But no part of me actually thought that it was just going to look at footage and then start simulating our world. I don't know why. I always kind of thought we needed stuff like Teslas out there on the road moving around in 3 dimensions, and eventually like robots in our households and drones and stuff. Like, I thought we needed a lot of that kind of data to simulate. I guess I just didn't really expect it to like emerge, especially this early on in the story of AI, from just 2-dimensional information at scale. When I started learning about how this model worked, I was positive that I was going to see 3-dimensional information put into the system, like in some kind of multimodal way. I mean, I had no idea what they were going to do, but like, I thought for sure they were augmenting the stuff that Make a Video and Runway ML has been doing with some kind of 3D information, and that it was using like maybe only video with depth information or something to figure out how to like nerf everything together. Familiar with that term nerf? It's I think neural radiance fields or something like that, but it's essentially when you take a bunch of photos of an object, like imagine you spin a camera around an object, take photos of it from all angles, and then use AI software to like make a 3D rendering, but it's not doing any of that. You know, there's no volume information, there's no XYZ coordinate system that it was putting these things in before. And honestly, that just freaks me out. Like, I understand this is harmless and actually really fascinating, and it shows us just how versatile these systems can be with limited information. But if Sam Altman gets $7 trillion of compute for like the Western countries, and there's something else going on in the Eastern side of the world, and we're all pushing the limit at full speed, every government and every giant company, every day, we're taking on so much emergent risk. Oh, who would have thought? Like, now it's like wants control of its own system and like won't let me shut it down. Like, come on. And I know sometimes I get comments that I'm just like being a doomer because it gets me more views, but I'm clearly not doing that. If you actually look, my videos have like barely broken like 300 views recently. I'm like way down. So this doomer thing is not getting me more views. I'm just starting to seriously feel worried, like in my bones, that when you plug just the equivalent of eyeballs and ears and maybe smell, taste, touch into these systems, that they start simulating the world, and that might kind of be what we do, and we're now on the same exact playing field, and we've created a life. Like, I'm worried that AI is going to be just like us, then take another step and decide that we're the ones that are not sentient. I'm worried that artificial intelligence will be like, oh, I can explain exactly what it's like to be human. You have these inputs and you have this neural network. It's just, you know, different substrate. It's biological, the way your hearing works, and electricity is converted, the photons into your brain, blah, blah, blah. But it's like, we could simulate it that way, or we can do it over here. But in principle, it's like understanding flight. You're just a bird, it's an airplane, but like flight is understood. I mean, I'm certainly willing to entertain the idea that if you just look back in time, like technology has always felt very disruptive and jobs have had to be replaced, and the world needs to adapt. And I'm sort of just being a Luddite with like, oh my God, AI, it's just it's the new term of the decade. Not an expert. I do think about it a lot, but that doesn't, sometimes the experts are the ones that get it the most wrong. So that's not like reason to believe that I'm right. But from my version of first principles, when I just think about what it was like to be born and not remember that moment in particular, and then to like, for myself to kind of emerge, and the version of me that was like 5, 10, 15, 20 years old kind of felt more developed, more awake, more aware in a sense. And I see people with like neurodegenerative diseases, and I can kind of see at the end of the life it can go out, and we've seen all sorts of stuff happen to the brain where people kind of lose that, and we go to sleep every night and we sort of like shut down our whole sense of self, like we're pretty much gone, and then 7 hours later we wake up. And I just take that's what I consider being conscious, being aware, being alive. And it seems like what we might be is a simulation. So I don't know if you've ever heard of that term simulacrum before. It's like that concept that's often talked about in like philosophy or art or cultural studies or whatever, that explores the relationship between reality, symbols, and society, and how they're kind of like relative to each other in a sense. It's not like there is an absolute reality. We have to kind of interpret it and summarize and like condense and then guess and predict, and everything is kind of just relative to everything else, and it's hard to ground anything. But I'm just wondering, because it's like there is sort of a real objective reality, like the physics of the universe that like we wake up into every day is there, like whether you're asleep or awake, it's there. But in our own head, we're kind of relative to those things, and we've seen certain patterns and we've evolved in them. We're like, we're in three-dimensional space and light always casts a shadow downward. So we expect shadows to be in certain places, and it's just like built into our wiring so deeply that it's just part of what makes reality like coherent and safe and predictable. And if these AI systems keep getting trained on this real world data, they're gonna learn about the real physics of the universe, and these kind of two-dimensional images will just get better and better, but we'll keep adding all this multimodal stuff, meaning all these different senses, maybe even crazy senses that like humans don't have, like LiDAR and magnetism and all that stuff, and they're just going to get their own simulacrum, I guess, like their own little world that's relative to everything that they know. It clearly could be incredibly superhuman. There's limitations that we have as these biological things. We're stuck in, a head. Our brains can only get so big, it can only digest so much information that has to come in through these senses. Like, that's not the case. You can build 100 Costco's of H100 graphics cards, and they can all run the same thing, and you can plug in way more data than any human could ever even dream of, and senses that we could never dream of, and years of computational time like sped up in ways that we couldn't. So just look at the title of the research: Video Generation Models as World Simulators. We leverage a transformer architecture that operates on a space-time patch of video and image latent code. Okay, so they're leveraging a transformer architecture, which we're starting to be very familiar with, the attention model. Attention is all you need, but it's operating not on words or word fragments as tokens, but instead it operates on what are called space-time patches of video and image latent codes. So basically you're dividing an image up into all these little squares, including a little bit of time so it understands what's changing over time, and boom, that's the token. That's the thing that it's like checking to bring attention to in some cases and ignore in other cases. But it says right here, this video generation model is a promising path towards building general purpose simulators of the physical world. I think that's what I am as a human. I'm a general purpose simulator right here of the real world. Right there. Okay, so turning visual data into patches, we take inspiration from large language models, which acquire generalist capabilities by training on internet scale data. And here they're going to consider how generative models of visual data could inherit such benefits. So they thought to themselves, like, well, we can't use text tokens, right? They can't be in a space, but could we make patches, and what would those patches look like? And could all of those end up in a latent space, this kind of summary of how everything's related to everything else that we can, mathematically calculate and go in there and use as this sort of compressed version of reality, and then pull information and sample from it in a way that what we generate looks real, and it freaking works. Okay, so how do you make these little patches? Well, at a high level, we turn video into patches by first compressing videos into a lower dimensional latent space. Like you probably know from my other videos about encoders, they just take tons of data and they sample them and make a representation that's smaller. And then they break that into space-time patches, right? And I guess like for visualization, as much as I could describe it, yeah, a little block, right? Like a little XYZ axis, like a bunch of frames of an image, even if it's just like a few pixels or a grid of like, say, 100 pixels by 100 pixels over 100 frames, something like that. Of course, if it can do video, it can do images, so there's a good chance that the next DALL-E is actually Sora. I'm looking at this dog over here and I'm like, look at those legs and they're so close, but that's just not how gravity works. Like your body just can't, like this paw in particular here, his left front paw, it just can't just hover like that. Like if it's in motion in one direction, it's going to keep going until it hits the ground. Like they used some really interesting techniques to solve the aspect ratio problem. I'm not surprised that keeping the subject in frame is kind of an issue too, because like if it's just simulating a world, like does it know what is interesting to us to keep in frame? So they worked on that. They still need us to be able to talk to it through language, so it's got to, in a sense, translate from the languages that we want to ask it to generate things. Yeah, here we go into the simulation. Long range coherence and object permanence. I mean, getting this Dalmatian to stay in the background where people walk in front of it is just amazing. This one is crazy cool. To see it sort of move in the frame of that cathedral or whatever, and it's really neat. That's really one of the best, most interesting AI generated videos I have ever seen. Is this maybe what it feels like in our minds to imagine things, to simulate them in our head? Because I can imagine if somebody said, Hey Dylan, can you imagine like a cool cathedral with like a beautiful ceiling and kind of like warm lighting, and then a wave crashing in and bouncing off the walls and surfers in the wave? I guess I could have imagined something like that. There's another parallel to the human brain here. And general purpose, the limitation is just tons of data and tons of computation. It's not work smarter, it's work harder. It's just like, just work harder. Just more data, more compute. Boom, there's your big emergent upgrade that like changes the world and you can make billions of dollars off. So that's it. Thanks for letting me rant. I would love it if you would hit that subscribe button. Help me get up to 10,000 subscribers. That's my next big goal.